All right, let's go ahead and get started. So I want to clear up something in the last episode. Um, I wasn't really trying to bash on KiCad or anything. It's a great tool. It's just it threw me for a loop the way it manages things like power ports that they're a part of a library you can accidentally disable. So I went back through and cleaned up, fixed my mistakes, so now I'll be able to add power ports to the design. But we'll get to that here in a minute because I want to go through and clean up a few things and uh, kind of clarify some stuff because I do want to stick to proper documentation and even ISO level controls on a project like this. So the first thing I want to do is go back into KiCad, edit the footprint. So here we named it as whatever it was imported as. So what I want to do is go down. So I've got the actual part opened up here. You can either, Mouser will typically show you what's called its package or its case, or you go and open the data sheet and it'll explain the package of the case, TSOT26. So for anybody who doesn't really have too much experience with electronics, that package or case, they are typically standardized in the industry. One of the industry organizations behind all this standardization was IPC. They've recently changed their name to Global Electronics Association. And in a nutshell, what these guys are, it's basically a consortium of manufacturers, vendors, companies that actually design electronic parts, companies that do actual design and building. They come together, they all discuss best practices in the industry. And by that, what they've done is they've created what's called standard packages. So if you've heard of like an 0603 resistor, an 0805, those are standardized packages that were created by the IPC consortium, the group. Most manufacturers do their best to design parts around an IPC, or I think it's I can't remember the other three-letter abbreviation. I'll dig it up. But they try to do their best to design a part around an existing footprint. Why reinvent the wheel when you've already got footprints that work? So in the case of our power supply chip, our power management chip, the buck regulator, it uses a TSOT26-6. What that means is any part that uses the TSOT26-6 will fit in this footprint. If the manufacturer is following all the proper guidelines and designing their parts around these industry standards, it doesn't matter if you buy the part from Analog Devices, Texas Instruments, it doesn't matter. TSOT 26-6 will fit on that footprint. So what we're going to do is, because that's a standardized footprint, we're going to go back into KiCad. We have to fix the mistake that we made. So we're going to rename this to a TSOT 26-6. And there we go. Now let's make sure that's kind of like how it is. TSOT-26-6. Okay. So it's named the TSOT 26-6. So now any parts we add to our library that use a TSOT 26-6, we can just automatically associate it with this. It'll already have the footprint here and the 3D step file of the component placed. These are great. I know in Altium and Circuit Studio, you can actually export a step file of the PCB with the components placed. Really great for if you're working with a mechanical design house who's designing an enclosure for you. That way they can actually test fit the board into an existing design using something like SolidWorks or Fusion. So that way we don't have to keep recreating a footprint over and over and over and over again. It saves a lot of time. So we'll save that. So what we'll need to do then is go back into our schematic library, our symbol editor, I should say, find that part, and this always drives me nuts because it's a little bit different than symbol properties. It's footprint we need to fix because now we changed the name, and I don't know how well KiCad takes to the name. Why aren't you taking that? Did something not get saved? Let's see here. File. Why are you mad at me? Let's see if it. I'm going to save all our changes. There. Okay. TSOT 2606. Okay. Why it wouldn't just save that? Don't matter. So now it's going to have the proper footprint associated with that. And any part we add will be much used in the future. Okay, so that fixed that. All right. So that component is actually fixed. The next thing we want to do, the next elephant in the room we want to address is generally you want to have a qualified vendors list or an approved suppliers list, something. We will create documentation later to help define that, but for now we're going to kind of create a file just to get us started. So it's going to be an SOP because hopefully you don't have to modify it too often in the future. So we're going to just kind of create our so we're just going to call it an approved supplier list. We'll modify it, we'll fix it up, we'll clean it later. But right now, we want to keep track of the companies we want to approve for supplying us with the materials. This way, if you build a company up and there's any questions on who you're supplying, who's supplying your products, you want to try to avoid companies that would be dealing with something like conflict minerals. That is a really big contentious point, and it can be a deal breaker, especially if you're looking for government or military level contracts. Any supplier that deals anything that has to do with conflict minerals is a big no-go. So having an approved supplier list, so one of the things we'll look for is companies that give certifications. They'll send you a certificate basically guaranteeing the products they sold you meet that criteria, that they're not manufactured using conflict minerals, they're manufactured in accordance with XYZ, such as ISO 9001, etc. So we're just going to kind of just get this real quick. Mauser. We're also going to, again, we'll work on fixing this. DigiKey. Yeah, we'll also put in JLC PCB. We'll even throw in PCB away. Yeah, I know I'm not very consistent here. So this is going to be the start. We'll get some more framework built up. We'll save that. Again, we'll get back into this later. I know a lot of people want to see design work, so that's what we're going to work on. So the next thing I do want to make sure we do before we get too much further ahead. Again, this series isn't just to design and to build. If that's what you're looking for, you can wait till they're on YouTube, and then you can skip to the parts that you actually want to see. Wait till you actually get to the videos. This whole idea is if you're trying to start a company, taking an idea from a breadboard and actually manufacture it or sell. It's easy enough to get, stars in your eyes to get the idea that, hey, I could do this. I'm going to run forward and just go for it. But there's a lot of pitfalls. There's a lot of things that can trip you up and nail you. And one of them is poor planning, poor budgeting. So one of the things I also want to do before we get too far ahead is also start defining inventory control. Because not managing what you have in-house or on hand to actually build boards versus your obligations versus what customers are ordering, it gets to be problematic. And if you don't wrangle this now, getting into the habits of keeping an inventory, monitoring what you have, it could cost you. It could ruin customer relationships and everything. So under Odo, what we're going to do is go to the grid menu here and go to inventory. We have absolutely nothing here. We have products. It's just the way Odo works. We have absolutely nothing in inventory. So we're going to add this voltage regulator to inventory. So what are we going to do? So the product, I typically have it the same name as in KiCad. So it'll be this PMAP, basically power management, and then the vendor part number. So let's just go and copy that. Go over here to Odo. We're going to do PM. Okay, so it's not a technical sellable part. We're not in the habit of selling parts. That's not what we're looking to do. Get rid of that. This really isn't, we're not going to be using Odo to track finances. I would recommend using something like QuickBooks or another package to track your finances. So here we have that. Let's see here, track inventory. We have 0 on hand. Our cost, I always like to use individual unit costs, 0.71. So category. We technically don't have any categories. So what we're going to do is we're create a new category. And we're going to call it power management. The parent category will be goods. All right, and we'll save it. Now the reference is going to be the same that we have in KiCad for that component. All right. Basically the description. So we'll copy that. Paste that in here. And then we'll purchase vendor Mauser. See if we can, so it's a company, hello company. Mauser.com. It'll be kind of generic, but it's fine. We want to have vendor product code as well. Uncheck lead time. So the vendor product code, we will use Mauser's part number for it. Go here, paste that in here. Single units. On control policy. All right. We're going to save it. So now that'll add it to the inventory control section of Odo. And then what's great is when we go to build the bill of materials for actually assembling these boards. Even the prototype level will have this. That way we can also create purchase orders to purchase. That way we can keep an inventory tracking. So that does that. We'll go close that out. So one of the other things we want to do is make sure we get the data sheets for important components, because one of the things we're going to pay attention to when we're ready to do the PCB layout is, let's scroll all the way down in here. So for one thing, it'll help give you a typical circuit, which is great. This makes life a lot easier. We could definitely kind of copy a lot of this stuff and migrate it over. So we have a typical application circuit, which is great. And then further down, usually, yes, right here. This is one of the second most important things on the data sheet. This will come when we actually do the PCB layout, but it's good to get into the understanding of it now. They give you the recommended layout, your polygon pores, how it connects everything together, basic traces just to connect like your feedback, your feedback loop, and all that. How you should set up your ground plane. Their best recommended methods for all this. You are better off trying to mimic this as closely as possible, because these manufacturers, they have tested this and done all their internal validation to make sure that this is the best possible configuration for PCB layout to reduce noise and operational problems. So it always will give you right here. So yeah, we'll use 2-ounce copper as recommended, but that'll come during PCB layout, etc. when we go to order. So just something to keep in mind. I would save the data sheets into like a data sheets folder associated with the project. All right. Again, this video is going to be me designing and adding parts to a library, creating a standard library, and adding parts to Odo, because this is the process. So if you're enjoying it, I'm glad to hear it. So let's go back to our data sheet. And this is honestly what we have to do to design our boards. Let's go to the typical application circuit. All right, again, recommended components. So our input side will be up to 24 volts. So now we need to kind of figure out, okay, that inductor right there, based off of this, it looks like a 2.2 microhenry should be just fine. And I've built boards with these circuits before, and a 2.2 microhenry works just fine. Now we're going to take some time here and let's get some resistors. Passive components, resistors. Chip resistor. Actually, wait a minute. Ignore me. Ignore me saying resistors. We're going to get capacitors. I was looking at the other one with the feedback voltage divider. We are going to look at MLCCs, multi-layer ceramic capacitors. They're going to be SMD. Now, because we can have up to 24 volts, actually up to 32 on the input side of this little fella, we want to make sure our capacitor is well rated. So let's see if we can get a 50 volt. Apply filter. And they recommend a 10 microfarad capacitance. Let's go find We will go up a little bit and look at a 22 microfarad. Okay. That's going to be a pretty sizable capacitor. 50 volts. All right. That's a pretty pricey capacitor, too. Now, what we can do then, let's go and drop that back down to 10 microfarad. Let's just go back down. Because we can put bigger bulk capacitors on our individual components. Let's go to 10 microfarad. It's going to be a big monster. We can always put a couple of these on there. There we go. 0805. X5R is okay. Yeah, 1206. Let's go see what we got here for. All right. Here's where the prices are a little bit better. TDK is okay. Here we go. TDK, 89 cents. Samsung, okay, they're pretty good parts. Here's even better, 22 cents. And that's a single quantity, but once you start ordering 10 or above, you start getting the bulk quantity discounts. And that's a Samsung, good quality brand, 22 cents. X7R dielectric, it meets all our requirements. Okay, so here's where things are going to kind of take a bigger twist. And again, it's going to be interesting because, so for one thing, you typically don't buy electronic components, passives like resistors and capacitors, based on the brand. Sometimes you do, most of the time you don't. Especially when you're talking the chip caps and the chip resistors. You've got multiple different manufacturers manufacturing pretty much the exact same parts. So you're basically just ordering from specifications. You're ordering based on, in this case, capacitance, voltage, dielectric, and package size. Now I'm trying to find my notes because with that in mind, we want to standardize on a part numbering system for things like chip capacitors and chip resistors. You can handle your brands based on your bill of materials. And to make our lives easier, we'll go ahead and download this stuff. Download the CAD models. Extract all. Because that's going to really help us with KiCad. I know KiCad probably had a bunch of this stuff already in here. But I like to, when I'm working with things, I just like to create my libraries from scratch. That way they're built up the way I like to work with them. And I recommend doing that the same. So we're going to need to come up with a part numbering scheme for this. That way we're not reproducing the wheel 100 times over for the same part that has the same specs. So what we'll do is we'll come up in here, close that, part naming conventions, SMD, all right. Now, typically, what I like to do, so for capacitor, I like to prefix it CC, and then in this case, let me let me drop this down here so we can kind of. All right, don't mind me dragging you along. So chip capacitor. What did I say? This is 1206. Chip capacitor, the package 1206, and then typical capacitors and parts will have a 3-digit value. That's 10 with 6 zeros after it, and that is in picofarad. So once you do the conversion, that becomes 10 microfarad. So what we're going to do then is 1206, 106. Its voltage is 50 volts. So we're going to do 050. And then its tolerance, we're going to go ahead, since it's the first one we're doing, AAA. So it is going to be prefix 3-digit value code 050, voltage. Oops, too many A's. Let's see, that will be 10%. Since it's our first one, we could organize it to where AAA is like 0.1%, but it's not necessary. I'm just going to jump this. And resistors will follow a very similar naming convention. Now, if we want, we could throw in the dielectric as well after that. It doesn't hurt. So that'll be the dielectric value of this capacitor. So in KiCad, we are going to go ahead and create this component. New symbol. You know what? Let's actually go ahead and import that. Import. We're going to import that symbol from here. That way we can just use the same one over and over again. But what we're going to do is we're going to we're going to rename that. Drop this guy down here. Fortunately, all this is changeable in the get you down here out of the way. Symbol properties. Okay, so here is where I wish I could just do it up here. File, Properties. No. Let's go and save that. So here is where your little snipping tool comes in handy. That way, I'm just going to move this off screen. That way, when we come up here, oh, cancel out of that. All right, come back up in here. That way we can mimic everything. Okay, that's our part number. Footprint we'll fix here in a minute. Data sheet according to this has to stay in here. Samsung. All right. This is where we're going to want to put in a usable description. Let's see. Yeah. Capacitor. Chip. It's a 1206. And then we'll want to put in the details about it. Okay. 10 UF. F. 50 volts. Other details that we might find. 10%. 10%. X7R, let's go and do that. And we'll want to get our operating temperature range. And my short-term memory is horrible. Negative 55 to 125. Negative 55. Now let's make sure this isn't like an automotive graded part. It's not, because we'll want to put it in here if it is. Be like I think it's AQ200 or Q200. I can't remember. One of those things. We'll when we run across it, we'll run across it. So now we've got the component created. We're going to look at our. Let's get that out of the way. One. You know what? Seems like let's see here. Let's just get these out of the way. It's just annoying. So, manufacturer 1, and it's Samsung. Part number, and we will make sure we copy the manufacturer part number. Our vendor would be Mauser. Part number. This guy up here. Yeah. This side of actual design work and engineering and designing a board, it's not the prettiest, it's not where the glory is, but it's necessary. Before that way I don't have to. Again, we're going to look at 1,000 parts as our high volume cost, even though the reels could be better priced. So it's 22 cents and 0.68. Okay. Now we're going to go ahead and save this. Because now what we're going to do is we're going to go to the footprint editor. Then we're going to go ahead and import that footprint. Now, once we get this footprint imported, we will can pow. Drag. There we go. All right. So now, yeah, that's got that number, but most of us know it better by the 1206 footprint. I have to select that. Okay, okay. Now, one of the things where I want to do is place. I got to remember how to place the 3D body. Only done it once. All right. I'll figure it out. We'll figure it out. We'll figure it out together. Cool. I did it on the last one, and I can't remember how I did it. Yeah. All right. Tools. We didn't have to do it by 3D view, did we? No. Nice. Tools. Three. Okay, it's under the properties. So we're going to. Hello. Okay, looks like I made it mad. All right, we're going to add. Download. Okay, so now we got the footprint, the part sitting on the footprint. To save. So now we can go back to the component editor. And then we'll go here, we'll go here. All right. Looks like a jumble of mess right there. Hello. Oh, yeah, I know what this is doing. So used to having to push shift to get out of my way. Okay. Hello. Please, come on. There we go. Okay, so now we've got that saved. We've got the part created here. And for the fun of it, I typically like also beating myself in the face and also add it to Odo at the same time. So we're going to hit new and go here. Cancel file properties. Sale. Let's go and put Mauser. Mauser part number. And what was the cost? 22 cents. General information. It's good. We track inventory. We're not tracking any of this. I think there's a point in here where we can. So we're going to create a new category. This gets easier down the road by having these categories to sort and monitor inventory and to find stuff down the road. So we're going to go back here, go here, grab the description. All right, bump, 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 bump. And the good thing is once we get this library built up, get the inventory created in Odo, designing will get easier because you already have this huge library of parts coming. So that is going to be the input capacitor. I'm going to grab that little fella. I think it's R. We're going to go ahead and... Oh. So we'll just go ahead and put two of them in parallel. That'll give us 20 microfarads total. All right. So what we'll want to do... What's our two input capacitors? Let's go ahead and grab our ground. Just go ahead and use that. Oh, repeated copies. Okay. Oh, okay. Now that I know how to do that. Now we're going to place another symbol. Okay, plus our anticipated voltage is going to be plus 24 volts. We'll go ahead and pop one of them, even though it can handle 12 volts for this. Let's go ahead and throw another one. This is going to be 3.3, 3v3. That's common there. We will place this guy over here. It looks messy for now, and it is. We will clean it up. So, can I rotate? Yes, we can. Okay. Okay. Well, KiCad is actually a pretty nice tool. After using Altium and other tools for quite a while, I will admit, KiCad's pretty nice. Hello. Oh, there we go. Let's drag you down All right. All right. Well, there we go. Okay. What's this? Draw wire. Draw bus. All right. So we're going to do wire. We're going to start. I'm going to start plugging this guy up here. Okay. So what we're going to do is we're going to grab all these guys, pull them down a little bit. There we are. Back over here. We're just going to go ahead and enable this guy default. That's going to take some getting used to. Pop this guy down. Okay. So that starts us on our 3.3 volt regulator. This is what's going to be used to power the ESP32 and a few various onboard components. So let's see if we can throw anything else on here before it's time to end the video. So let's go and close out the DigiKey. We can add them as a supplier later. 100 nanofarad. That's a 104 capacitor. One thing to keep note: those things you will use like water. They are in manufacturing. We would buy those things 10, 20 reels at a time. That's how often you'll use a 100 nanofarad. They're very commonly used. So let's go back to here. That should reset our search results. So 100 nanofarads is 0.1 UF. Let's see here. We want to kind of go 0603. So that's going to kind of, let's see if we can find X7R. And what's good is we got a 50 volt variant right there. So let's see here. Yageo, I've been using their parts for quite a while. Zero problems with them. Zero problems. And the price is pretty good. And then when you start getting into higher manufacturing quantities, your price really goes down. At some point in time, buying parts like this in the reel is just becomes more desirable. So 10 cents. I mean, and look at the stock quantity on that. What, 63 million? Yeah. And that's just what they have in Yageo stock. Kyocera is another good brand. So just keep in mind, I'm not taking one manufacturer over another. Yageo is good. Kyocera AVX is good. Taiyo Yuden is good. Kemet, another great company. Samsung, Vishay, yeah, they're all good companies. I just, Yageo. So let's download that. That way we can start our library. Again, once we get our library, all we really care about now is the 0603 footprint. The symbol we'll just reuse from the prior part. So it actually does get easier. We're going to extract all that. Yeah, the only reason I'm doing this is because I know I don't have footprint in here. And KiCad for that. Go back to here. And again, this part you're going to use like water. Designs everywhere. It's primarily used to help filter out noise, help set up timing circuits. It's used on PIX and the ESP32 on their enable and master clear pins, respectively, to basically delay their power up, their initialization until the main power supply rails are stable. It just kind of gives them a slight delay through an RC network. Okay. So let us get into KiCad. All right. We're going to close that out. You know, before we get, let's get a little crazy here. Let's go here. And we're going to import a footprint. 104, KiCad. All right. We're going to call this cap 0603. In the components library, bam. I wish you could right click and do properties instead of going up to here. So we're going to delete that. We're going to go to 104. Boom. Now we've got that set in place. So now we could go over here. So now the good thing is in the future when we add 12, 0603 capacitors, we don't have to keep creating the footprint. We have one already created. It's just a matter of creating the part. So let's see if we can do something here. If we can, I wonder if we can duplicate this. Ho ho! All right, let's rename it. Oh, 0603. It's gonna be 104. 50 volts. What's our tolerance? 10%. And X7R. All right. Save. Go in here. Let's cap 0603. Just get rid of that capacitor chip. 10 UF 50 volts. Let's see if this all fits. 55 to 125. 125, no big deal. No, 125. And it's not an automotive standard. That is perfect. So that's pretty good. So manufacturer one, we're going to clean this up. Yo. The fender is going to be the same, and their part number is going to be up here. And what's our cost? 10 cents and 012. 2 and 10 cents. All right. We're going to save that. 63104. Might keep this open because, like typical fashion, we want to throw it into Odo. Okay. Oh, get out of there. Category capacitors. We've already got it. So this will get a little faster as we go. Get our description. All right. Come over to purchase. Mauser. Get our Mauser part number. And we're going to say 1 10 cents. All right. Boom. Get back over to KiCad. We'll okay that. We'll save that. Come back to our design. And before we do it, let's see where that is supposed to be used. That's a 100 nanofarad. So that's going to be between the boost and the switching output. So let's place our new component, CC0603. Now that's a little bit too big. I'm not too terribly happy with how that looks. That is a little bit big, a little excessive. But, you know, we'll make it work. I'm not going to cry about it. Because I can always go in and edit this symbol real quick, make this bigger, taller, basically, drag the bottom down, move these guys. But for now, I'm not going to worry too much about it. Actually, no, what we're going to do is we're going to get rid of this. Actually, my bad. Since it just goes here. Since this is just part of the, it's just, yeah, my goofiness. Let's just do this. Make it a little nicer. Let's not worry about that. All right. So out of that recommended schematic, what would be left to do? So we're going to need to get the inductor and the output capacitors, basically the bulk capacitors. Those are 22 microfarad, but we can get them at a lower voltage, like 6 or 10 volts. That should be fine because we're only at 3.3 volt. But we could go with larger. See what we can do. See what we can do at 22 microfarad. All right. You know what? Maybe we can just finish this out. Run the video over like an hour, over an hour. But that's fine by me. We really have 2 more parts to add. Let's just go ahead and do it. Let's get 22. Let's just go and get our 2 capacitor, or our bulk capacitor, 22 microfarad. Let's just go and do that. All right, let's go ahead and do 22 microfarad. Let's see. What's a 25 volt? What package are we looking at here? Oh, we can do that 0630 0805. What dielectric? X7R. Oh, it's fine. We'll stick with that. We'll go to 1210. Let's see who we got here. 99 cents, $1.26, 95 cents, 82 cents, 73 cents. Does Yagyo have anything? Tayo Yuden, 60 cents. It's not terribly bad. Tayo Yuden, I've used their parts before. 43,000 in stock. Let's just check. Kind of give you an idea how well they're stocked. See, that's 158,000 in stock. Yeah, you know what? We'll pay a little bit more. That's a 20%. What's that 60-cent unit? It's a 10%. That's not bad. 25 volts, 22. You know what? That's not bad. And that stock quantity is not terribly bad. So we'll just go ahead and use this. That is going to be a 1210 package, which is great because we're going to be building up our library again. Let's download. The good thing is we won't need the symbol. We just need the footprint. And for anyone still watching, I really appreciate you sticking with this video. I know it's nothing exciting. We're not playing any games or anything. But this is the process. This is the process I go through for any new design, anything I make. This is unfortunately the nature of the business. It's not all glory. It's not all super interesting stuff. Doing this work is just as important, but we're getting kind of a hang of this. So we're going to download. I hit the wrong thing. File, import. I meant to open, I hate that. TMK. So used to having it shift. No. Ugh. Just drag. Okay. Side of that. 1210. Okay, ignore me. Okay, we're going to save it as cap 1210. And I've got my cat Henry with me again. He's purring away, trying to help me. File, footprint properties. Oh, okay. Okay, come on. Get the hang of this. Slap that guy on there. Boom. We're going to save it. So now we have our 1210 capacitor. All right. We're going to duplicate because that makes it a little bit easier. It's going to be CC 1210 226. What was the voltage? 25 volts. 025. Tolerance is 10%. AAA. And X7R, if I remember right. My short-term memory is horrible anymore. I'm going to copy that because it's going to make it a little easier going here. We're going to go into... wish I could right-click on that instead of doing this. All right. Component cap. That's a 1210. Okay. We're at 25 volts. 10% X7R. What is our temperature range? -55, 125. So Rojas, is this an automotive capacitor? No, it is not. Perfect. It's a Taiyo Yuden. I don't want to spell that. Did I spell that right? All right. Manufacturer part number. Vendor part number. And 16187. I should keep that open. I'm an idiot sometimes. Plus, I'm also used to using two windows to do all this. Mauser. Back here, get the manufacturer code, product code. General information, track inventory, blop, blop, blop. We're in capacitors. Reference is going to be the description. See, this way everything will match between BOM, work order, even a label. I haven't gotten into yet. I'll get into that later. I have a label printer I picked up from Amazon, that a nice Zebra printer I use to make labels for by inventory. We'll get to that later. Purchase inventory. We literally nothing in here. We're going to save that. Come back to KiCad. Actually, it's easier if I just minimize that. We're going to okay. Go ahead and save that. Go back to our design. Pow, pow. Okay, little cat. You're blocking my way, little dude. So, I don't know. Hey, stop opening windows I don't want opened. Stop it. All right. So there's going to be an inductor that goes here. So we're going to drag this little fellow over here. Hey, stop it. Stop it. Play along. KiCad, you're as bad as my cat. Actually, in here. Throw that in there. So now we have our output volt capacitors. Just help with more rapid voltage transients. All right, now we'll come over here. Let's go and save this. Now we need to find this little inductor, the 22 microhenry. So we will go here, products. I prefer to do here. No. Inductors, chokes and coils. So that's technically a power inductor. We know our 2.2 microhenry. Make sure we're not. That's milli. Okay, 2.2 microhenry. There we go. Come on. So many to choose from. 2.2. Go ahead. Now we will look at our current. Now I think this thing is capable of 2 amps. So we want to see if we can size it maybe 2.5 to 3 amps to deal with any kind of surges. Let's see if we can do a 3 amp. All right. All right, perfect. Pulse is pretty good. Worth is pretty good. Bechet, Worth. Borns, okay, 33 cents. 2.2 microhenry, right? Just make sure because it's so easy to yep. 2.2 microhenry. That's not bad. 33 cents. Be a good size package. Oh, there we go. 97 cents. And I would recommend not jumping to just get the cheapest possible. You also want to make okay. That's you definitely have to buy in high quantity for some of those. Epcons 2.8 amp. That's good. Again, like I said, you want to make sure that your inductor is big enough to handle. Even though it's rated for 2 amp, you still have to deal with surge current. So we want to make sure that we're okay. We're sized appropriately. Epcos TDK 1200 in stock. That may not be that bad here. What's your voltage or current limit? What are you rated at? 3 amp. Okay, okay. Let's see how big of a chunky guy you are. Right. Are you shielded or unshielded? You're shielded too. Okay. You know what? 33 cents is not bad. It's a good size inductor, but it'll handle 3 amps. I say we go with this guy. Let's go and download the CAD models. All right. Lather, rinse, repeat. Lather, rinse, repeat. All right. So SRP. Extract all. So for anybody just casually watching, this is one of the things that causes hour consumption. So if you're contracting out an electronics design house, this is one of those. This is part of the process that causes that consumes the hours. It's just finding the parts, making sure they meet spec, building up the parts library, adding them to the inventory system, adding them to your designs, your ECAD software. So this is what we're going to use. So, okay. So let's go back over here to, now let's see here, is a inductor 1005 package. So we're going to come over here to our footprints. We're going to file, we're going to import a footprint. SRP. Open. All right. Save it. And we're going to keep it inductor And what I say it is 1005. Okay. File, footprint properties. Probably didn't have to do all that extra stuff. All right. All right, now we're going to come over here. Since we don't have an inductor added, we're going to go ahead and import a symbol. I do like this to get ourselves started. That's pretty cool. KiCad, we're going to pull that guy in. So we're going to go ahead and with inductors and other parts like this, typically I won't create a fancy name for them because they can vary wildly between manufacturers and their packaging case. So a lot of times, especially with parts like an inductor and other things, I like to keep the manufacturer's part number as part of it, but prefix it with L, which is typically used to indicate an inductor. So what we're going to do is we're going to drag that guy down here. As noisy as that stuff is, I'm going to stop messing with it because it just gets annoying to mess with. Save. We're going to go to File, Symbol Properties. Let's get rid of. I hate that you have to have that. Okay. Let's go and get the. Let's go and get this cleaned up. Inductor, power. I think it said it was shielded. Oh, let's double check. It is shielded. Alt 230. Henry. 2.3 amps. Is there. Anything else? Nope. Negative 40 to 125. Oh, that's pretty hot. Inductor, power, shielded, blah, blah, blah. I'll refer to our little stitches. So we're going to add menu. One. And who makes this little guy? Borns. Spell Borns. Go here. Vendor 1A. Mauser. Vendor part number. Now again, you can find these parts on DigiKey. You don't have to use Mauser. It's just a company I've been using for years. Low volume. High volume. So 33 and 199. All right. Okay. Okay, that is good. Now footprint, let's get that chosen. Is inductor 1005. We're gonna hit OK. We're gonna save that. So any future inductors, we'll just copy this. Go back over to our design. We're going to place our new inductor. Boom. Now I'm going to drag this kind of over a little bit. There's one last line to meet. Be back. All right. So there we go. So we have our. That's off the wrong. Okay. All right. I'm going to shoot myself in the face right now. Oh, wait a minute. No, it's not. No, it's not. My bad. No, it's not. Never mind. It's off the switch. Yeah. So we have the boost between the switching output, and then the switching here, feedback after the inductor. So that should meet this guy. So here's the boost between the switch. Here's the inductor output after. So here we go. And then our two output bulk capacitors to help clean things up. So we're going to grab all that. We're just going to kind of tuck this up here, out of the way. And there, we have our first circuit actually designed. It's going to be our 3.3 volt output. In the next video, we will capture the design on the more likely maybe a 5 volt power supply. I'm not sure. We'll look to see about a fan to help actively cool the design. If we can find a small enough 3.3 volt power fan similar to the ones used on the Raspberry Pi, maybe we'll go that route, not even worry about designing another power supply. But I have a feeling we're going to have to do a 5 volt supply just to operate the fan, which is perfectly fine for the cost of the parts and to get a more professional grade product at the end. It doesn't bother me in the long run if we have to add a 5 volt supply. The good thing is the 5 volt supply is going to be an exact duplicate of this, with just this chip different. The only difference is that 3 is going to be a 5. It's the exact same part. Everything's the exact same. It uses the exact same input circuitry and output circuitry, so it'll be a breeze. We'll only have to create one part for that. So that's our power supply schematic captured for the 3.3 volt. Can we throw in... Oh, okay. We can throw text box. Oh, okay. Supply. I like to 3.8 to 32 volts. Kind of keep some notes in there. Oh, that's cool. Let's clean this up a little bit. There. Kind of note anything special. That way we can kind of keep track of what's going on. All right. Well, I thank everybody for hanging out with me for this hour-and-a-half video. I'll get this video edited and thrown on YouTube hopefully within the next few days. There are 3 additional videos I've already recorded on this series that I'll get on YouTube. I'll probably upload the next one, number 2, tonight real quick, and then hopefully I can get in and do this do another stream and recording session tomorrow, or let's see what's tomorrow. Tuesday? No, tomorrow's Wednesday. So either tomorrow or Thursday. Definitely be streaming Saturday and Sunday at 2 p.m. for more additional episodes. Thank you for watching, and catch you later.